In 2023, we're given this diagram and we have waterfalls in a national park, and they ask us to use an appropriate algorithm to find the minimum spanning tree. So I think we'll go for Kruskal. Kruskal is take the lowest, which in this case is HF. HF is equal to 4. Then continue to take the next lowest and the next lowest without creating cycles, and we should get there quite quickly. Is HJ next? That's 6. HJ. Then it looks like we have DC. That's 7. CD or DC. Have we any 8s? We do. We have an 8 between J and I. Or I and J. 8. Is that all the 8s? Looks like all the 8s. Have we 9s? We have a 9 between C and E. Any other 9s? We do. We have a 9 here. L and K. We haven't created a cycle. Have we another 9? Doesn't look like it. Up to 10s. Okay, CF. Doesn't close it off. CF at 10. We have a KI at 10 as well. Looks like here. IJK, IK at 10. Any other 10s? They look like the only 10s. 11s. That work. EG works. EG is 11. So does AD. AD is also 11. And so is EH. But look what happens if we do EH. It closes off a cycle or creates a cycle. So EH, we put it down and say no to EH. Is that the last 11? It is. Have we a 12? We have a 12 here. That's also going to create a cycle. GJ. Can't have GJ. With 12, I've got 13. We have FI. Again, creates a cycle. No FI at 13. We need to get to BAG. 14 is next. GH closes off. So no GH. No GH. Next is 16, I think. BE, I think that creates every node. Gives every node a connection. BE at 16. And that creates the minimum spanning tree. What does this add up to? 10 and 15 is 25. 45 and 18 is 63. 22 is 85. And 16 is 91. That's the algorithm we've used here. The next part of the question. The park entrance is at A and the exit is at L. We want to use our minimum spanning tree to calculate the time needed to enter the park at A, visit every waterfall, and leave at L. A to L. So if we enter at A, we can go A to D to C to E. This is where we have a problem. We're going to have to go B and back. We're going to have to go G and back. And then we're going to have to go back to C. So it looks like we have 2 of each of those, and then we can complete our cycle around G or F, H, J, I, K, and then L. So that looks like it. So it looks like we have an 11 and a 7. Then we have 2 9s, 2 16s, and 2 11s. So 2 9s, 2 16s, 32, 2 9s, 2 16s, 2 11s. Then we're back to here. We have a 10 and a 4. So we have 14. Then we have 6 and 8, another 14. Then we have 10 and 9 and 19. So what do all these add up to? they total 137. In part B of this question, we have a differential equation. And if you got a fright with the dog barking, so did I. So we're going to have dn over 2000 minus n is equal to k dt. And if we integrate both these, we have some other information at the start of their learning. So when time is 0, they know 250 words. And then we have it between n and t. So that's 2000 in there. I see I'm missing 0. So if we integrate this, we're going to get the natural log. It's like 1 over. So we're going to get the natural log of 2000 minus n. But if we differentiated this, the natural log of 2000 minus n, we get the natural log of 2000 minus n. And then it'd be times, there would be a minus 1 in here, wouldn't there? So we need to take account of that. So if we differentiate this, we're going to get 1 over 2000 minus n times minus 1. So that's, we definitely need this minus 1 to counter that, to make it a positive. So we're going to have minus ln 2000 minus n between n and 250 equal to kt, integrating the right hand side between t and 0. So putting n in first, we're going to get minus ln 2000 minus n, and then minus ln of 2000 minus 250, 70 and 50 equals t minus 0. So we want n in terms of k and t. Okay, so the left hand side, if we look at it as a subtraction sum, the first one will come first. So there's the positive first, the natural log of 70 and 50 over 2000 minus n is equal to t. There's a base e here that we don't see, so e to the power, that's kt. E to the power kt is equal to 70 and 50 over 2000 minus n. So 2000 e to the power kt minus n e to the power kt equals 1750. So dividing by e to the power kt, I get 2000 minus n is equal to 70 and 50. I know I could have done this a bit simpler, over e to the power kt. So n is equal to 2000 minus 70 and 50 over e to the power kt. So this is n in terms of k and t. Next, part 2, after 6 hours of learning. So when t is 6, n is 1500. We'll have to find k. So t is 6, n is 1500, and t is 6, 2000 minus 70 and 50 over e to the power 6k. So we bring that to the left, 70 and 50 over e to the power 6k equals 2000 minus 1500. So 500 e to the power 6k equals 70 and 50. Dividing by 500, with that divides evenly 3.5 times. E to the power 6k is equal to 3.5. So 6k by the natural log of e is equal to the natural log of 3.5. So k is equal to the natural log of e is equal to 1. The natural log of 3.5 divided by 6. Natural log of 3.5 divided by 6 is 0.209. And this is words per hour. And the last part of this question, you were asked to sketch it. So just use the equation in this format, put your values into your calculator, sketch this question, and move on to question 8.